I first became aware of Allan Holdsworth's invention called the harness in 2007. His mysterious handmade unit was for sale on eBay and I saved some pictures of it. I asked about it on a forum with some very knowledgeable people and no one there really knew exactly what it was. After I got my Yamaha UD stomp and was creating a web page about it, I stumbled upon a picture of another harness up for sale on Reverb, and I was able to see the inside of that one. That piqued my curiosity once again, and once I found a few more pictures of some of Allan's own units, it shed some light on what he was doing and some of the values of the components inside, along with reading many interviews with Allan. I have a few web pages about this harness, aka Juice Extractor, not talking about Rocktron's completely different circuit working on a different principle. If you want to know all the details of what it does, what the components are, and the overview of the convoluted story behind it, you can visit my website. Follow the links below. Okay, so what does this harness/juice extractor thing actually do? In simple terms, what it does is replace the speaker in a tube amp and it becomes a power amp to line level interface. Using this device, you can have the volume on your amp cranked to 5 or 6 and silently take advantage of the unique character of power tube distortion, transformer saturation, sag, etc. Allan would take the output of the juice extractor and feed that into parametric EQs. That in turn went to 8 different delay units to get his somewhat subtle signature sound that I've not been able to achieve until I acquired the UD stomp that has up to 8 parallel delays. Now that in turn went into another amp with an actual speaker where he could record things at normal conversation levels. I have a feeling this was a necessity is the mother of invention kind of thing here. Now I am not one to believe that tone is all in the equipment, it's really in the fingers. But I think in this case, the way Allan did his signal processing, it really is kind of one of the X factors in his sound. Many people considered his sound around the time that he was using the juice extractor a lot to be his best tones. You can hear it in action on Allan's Secrets and Hard Hat area albums or on Chad Wackerman's 40 Reasons. Allan had 2 official versions of what he called the harness, marketed under the brand name Sonic Tools, because Rocktron was using the juice extractor name at the same time as when he was building these. One was for master volume amps, known as the Harness, or also known as the Harness 1, and the other one was called the Harness 2, and it was for non-master volume amps. Allan also made a few custom units for people too. Since I have the most information on the Harness 1, in my quest to understand it and learn its secrets, I decided that I would have to reverse engineer it and make a work-alike so I can do some testing, but using only pictures. I have done this on occasion with other guitar effects and amp-related things, so it's not that big of a problem to do if you have enough info. This device is actually remarkably simple. What's not simple about it is the complex set of interactions going on inside of it. Allan's device is much better than a pure resistive load because it presents the amplifier's output transformer with a reactive load. This will sound better and will feel like a speaker. So with all that out of the way, this video will be about my process of building a clone, explaining the components and what they do and so on. My only intention with all of this is to highlight Allan's invention, how it works, and to give him all the credit for his very clever invention. As I would normally do on a project like this, I start by importing a picture of what I want to recreate into AutoCAD, and then I basically trace over the top of it to derive a full-scale printable document, which I can then use as a template to build whatever it is that I'm going to build. What are these parts inside? Well, the white cylindrical things are air core inductors. Spools of enameled wire efficiently wound around a plastic bobbin with a certain number of turns of a certain wire gauge to achieve a target inductance and power rating. These are what mimic the guitar speaker voice coil inductance. Underneath the coil shield are a pair of coiled nichrome wires which provide the resistive load needed for the output transformer. These can handle far more than the stated 100 watts power rating. The signal from the guitar amp speaker jack gets routed through these components in a specific way, which I will show in the build section of this video. Wired in parallel with these items is the line level output. So I decided I'm going to go ahead and put a 1/4 inch plywood base on this thing to make it more sturdy. And this is just a piece of scrap plywood I had laying around. And I went to Walmart and bought a cookie sheet for like 15 bucks. It was, what was it, 21 by something, and I cut it down with a hacksaw. So I could get this aluminum metal plate, and I've marked where all the holes need to be drilled. That's going to be one of the next things I do. And I used that printing out full-size layout of the chassis that I drew up with AutoCAD. It's at my website, and so that's going to be the next step. So here I have everything partially mocked up. I'm just kind of making all of the locations official and figuring out where everything needs to be, because these spools are slightly bigger than are would in Allan Holdsworth's units, and still awaiting the parts to make these nichrome heating element resistors and these terminal blocks. And I made these tabs so that I can, because I don't have a rack chassis to put this in, I made these tabs so I can have a place to put the output jack and the line in from the amp and the level control. And so the next thing I'm going to do is take this piece of aluminum that was donated from the cookie sheet that I bought at Walmart, and I'm going to drill all the necessary holes, all the ones that I can, and I'll finish these other ones when I know what size holes specifically I need, because I don't have them in hand to know what size screws going to fit through them. And then I can start the wiring once I get my 5 solder lug terminal strips, which I'll have 4 of them in here, just like Allan's unit. And I'm also awaiting the inductors from Parts Express. I ordered one just to do a test, and then I decided, this was before I decided I was going to actually just build the whole thing and recreate what Allan's has in his rack unit. So I'm waiting those. I got 6 more of those coming from Parts Express. They were like $6 a pop, and so we're getting real close to getting it done. So at this point I have almost all of the holes drilled. I have the majority of the bolts located that will hold the inductors down and stuff, and when my Parts Express order finally gets here, I will drill the holes for the terminal blocks, and we'll get all the inductors installed into their wire spools, get them bolted onto here, and get my jacks and potentiometer installed, and get these holes drilled, terminal blocks on. And then when my nichrome wire arrives, I'm going to basically make my own coiled nichrome wire, because I cannot find anything that's close enough to what Allan used. And I think by winding my own, I'll get pretty close to what I believe he used in his unit. So that's our progress so far. Just a quick word about these wire spools. These originally started out as 2-inch tall spools that had this wire around it originally, that I had bought like 20 years ago to build some scratch-built tube amps. And this is 18 gauge stranded wire, which I'm going to use in this harness build. And so anyways, I cut these down from 2 inches tall to about 3/4 inches tall, and they had yellowed due to age, so I painted them with some white spray paint that's made specifically for plastic. And what I'm going to do, like I did with the one inductor that you saw on the base plate earlier, I put the air core inductor on here, and then we super glue the top on, and then that gets a 1.5 inch round fender washer on top of it, and another smaller washer, and a nylon nut, lock nut, whatever you call that, which once that's on there, it will ensure that it does not come loose, and to get it perfectly centered on that bolt. Now the way that I came up with to get the spool centered exactly on the bolt is I cut down pieces of this wood dowel that happens to fit perfectly inside of here, and I drilled a hole in the center of it, and that's the size of the nut, and that will allow me to get it perfectly centered on the bolt. I skipped some of the intermediate steps as far as videoing it, but I have this thing almost done now. The only thing I have left to do is the nichrome wire, which I'm going to have to basically create my own heating elements that are close to what Allan used, because I can't find anything that's similar enough to it. So I'll go over that when I get the wire. I think it's coming in the mail today. And as you can see, I've got the terminal blocks and all the inductors installed, and all the 5-lug terminal strips wired up. I wired it the same exact way that Allan did his unit. And so right here is where the speaker, this is coming from the amp from the speaker jack, and then this is the output jack, which would go to your line level device, and of course your level control. So when I get the wire, I will do a little video about how I have to hand wind those to make them like a springy thing from a straight wire, and hopefully that's not going to be too big of a pain in the rear. But we're getting very close to actually having it done. And this thing got substantially heavier. I'd say it's a good 5 pounds now because of all this copper wire for these 7 inductors. So here I have one of the coils wound. This is 18 gauge nichrome 80 wire wound around a 1/4 inch dowel. That's how I created this, hand wound. It's a little hard on the hands, but I managed to do it. Originally I started out with this 1/4 inch round piece of wood, which you can see me winding it here. And when I was done, I ended up with this approximately 5/16 inch round coiled wire, and it just looked too big compared to Allan's pictures of Allan's units. So that's when I decided I was going to rewind it and make it a little bit smaller. I think this is still just a little too big. I think probably the internal diameter of the wire in his units is like 1/8 inch. The other thing is I have no idea what gauge wire he used, which interestingly is a much bigger factor than I realized. As we can see here, there's also 3 different kinds of nichrome wires, a nichrome 60 and a nichrome 80 and a nichrome 90. Now, the 60 refers to the amount of nickel that's in the wire. So nichrome 60 would be like 60% nickel, and 20, I forget. There's chromium, and there's also 24% iron. And nichrome 80 is like 80% nickel, and the balance of that is mostly chromium and 1.5% silicon. So, and you can see here too that there's a significant increase in resistance per foot for each gauge you go up. So every time you go up a gauge, it's about 25 to 30% more resistance. So kind of knowing what this gauge wire is actually fairly important for being able to accurately reverse engineer this thing. With this 18 gauge wire, this thing measures about 5.9 ohms from here to here, so we can have another one in between there. You know, we're looking at basically 12 ohms of resistance, not counting all of these inductors. So it's kind of hard to determine what exactly this is supposed to be. I don't know what Allan's units measure. If you measure from tip to ring here on the speaker jack, you know, what is that? 8 ohms, 10 ohms, 12 ohms, 15 ohms? I have no idea. So without having one in hand to analyze, you know, I'm completely guessing and just looking off pictures. I don't know how critical this really is, honestly. As long as you're providing an 8 ohm output transformer with a higher load, it's probably going to be fine. You don't want to present a 8 ohm transformer with a 4 ohm speaker load, because that will probably fry it, because the current significantly goes up. So this is probably okay. It might change how dynamic it sounds. Maybe it'll sound more spongy. That's probably one reason why also Allan had these switches on here where he could switch these inductors in and out on these custom units so that you could dial in exactly how dynamic or spongy or saggy it feels. Now, the one other item, the last item really, is I need to get a resistor here that goes to the input of the level control, and I don't know what exactly Allan used there. I simulated this circuit in LT-Spice, and I ended up needing like a 4.7 megohm here to get this line level output jack to like line level. If you use too small a resistor, I mean, you could slam your input of your preamp or whatever with like 7 or 10 volts peak to peak if this resistor is too small, and you're going to be beating the heck out of the input of whatever you're plugged into. So that may be one reason why Allan said, you know, start at 0 and turn it up very slowly until you get what you want. So that's where we are at now. When my nichrome wire gets in, I'll wind up the other length of coil here and get it installed, and I can start doing some tests and try to determine how close this might be to his units. When I was reviewing some of these photos I have of the harness, I noticed in this particular picture that the nichrome coiled wire here looks to be just about the same gauge as what I've used in my clone here, maybe even slightly thicker. And the overall diameter of the coil seems to be about the same, so I may be pretty close actually to what Allan used in this unit. I wound my second nichrome wire coil here, so this part's done, and curiously these values change a bit when you put things in the circuit. Like this coil by itself measured 5.9 ohms, and when I added this one in here, this now measures 3.5 ohms, and this coil is 4 ohms. So the two of these together are roughly 8 ohms. But the entire DC resistance of the circuit measures 13 if you measure between the ring and the tip here, which is kind of odd to me. And also I failed to mention earlier the apparent inductance of these 1 millihenry air core inductors goes up by about 42% when you add the washer and the bolt and having them on a metal base plate. So the overall increase in inductance of the circuit's like 42% when you measure from the ring to the tip here. And now Allan mentioned in one article that I read that he says that these nichrome wires have an inductance thing going on with them, but I measured these and they're only measuring 0.03 millihenries. So technically, yes, there's a little bit of inductance, but that's a tiny, tiny amount. So the other thing we did is we got ourselves a resistor here. I pulled this off an old junked oscilloscope. It measures 3.57 megohms. It's a precision resistor. That's what it's supposed to measure. Okay, so I'm finally going to tell you how the signal path in this thing works. What happens is the positive of the speaker comes into this first coil, goes through a wire here to the next coil, and then there's a jumper here, goes to the next coil. Then there's a wire that comes back here, and then at this junction another wire comes here, so that's the white wire. Goes to this first coil, and then it goes to this inductor, through this other coil, nichrome wire coil here, and then it comes back to here. At this junction we have this yellow wire that comes over to here, then it goes through this coil, and then we have this jumper here, goes through that coil, and then we have this green wire that goes to this coil, and then the output of this coil goes to the ground or ring connection of this speaker input jack. Now we have also in parallel the level control. So that's what this brown and white wire does. It comes off this jack, comes over here, and then the ground connection or the ring, if you will, goes to the ring. So all these rings are connected together. That's basically our ground. The white wire, or we'll say the hot, goes to this terminal lug strip here, and it goes through this resistor, and then it goes to this 250K pot, and the output of which goes to the tip of the line level output. And then of course the ground wire connection also connects to this point here. So that's the signal path. I guess this is going to have to be in a part 2 video. I'm going to figure out exactly how to test this so I can figure out frequency response and that sort of stuff before I maybe plug it into one of my amps and risk frying an output transformer. I don't think I would fry an output transformer, but so this is the Allan Holdsworth harness.